So let's take a look at a couple of examples to help us determine whether we have direct or inverse variation. We can see that x times y is equal to 5. So x times y is equal to a constant value. This is our a right here. And because that product of x and y is constant, we can look here at our inverse variation and see that that's the form of the equation we have. Our product of x and y is constant. So our product is equal to a constant. So we are looking at this one right here, that version of the equation. So we can see that we have inverse variation. All right. This next one, we've got x and y on different sides right now, and we can go from this particular version of the equation and rearrange it to get x and y on the same side. So let's do that. The first thing that I'm going to do is I want to move the 2 over to the right. So I am going to multiply by 2 in order to move it. So I will end up with y is equal to 2x. From this version of the equation, we can actually look up here and see that that is this equation right here with a value of 2 for a. So we can either stay with that version of the equation if you would prefer to rearrange it to have x and y on the other side. We can do that as well. So we could divide both sides by x and get that 2 is equal to y over x. So we can see distinctly that our quotient is a constant here. That means that we have direct variation. Again, most of you would have been able to tell that it was direct variation once we got to this point, but I just went ahead and rearranged it to solve for my constant for my a value, just to make it a little clearer if you needed that clarification. All right, this final example on this page shows that y is equal to x minus 4. I don't see any multiplying or dividing here. If I wanted to get x and y on the same side, I would be subtracting x from both sides to do that. So this is not multiplying or dividing. So that means that it's neither. Remember, it has to be either multiplying or dividing to get a constant in order for it to be inverse or direct variation.